Okay, so I want to show you how to complete this virtual earthquake lab, which helps you find the epicenter of an earthquake, just like a scientist would do. They might use computer models, but it's really the same process. It's something called triangulation. And scientists do that by using P and S waves. And P waves are the fastest that occur during an earthquake. They're called primary waves. And then secondary, right? It kind of makes sense. The second wave that arrives. Secondary waves, these have different motions. Primary waves are like this compression and apart and together kind of wave. And then S wave is like an S, like a serpentine kind of motion. They have different ways they move. But primary waves are faster than secondary waves. And they're very consistent. It doesn't change. So they can make a prediction because they know the different speeds, and when one arrives and when the other one arrives, they can use that to figure out how far away the epicenter is. Okay, but they only know a radius. We'll kind of I'll show you this. So they use triangulation. So the first thing you want to look at are these seismograph readings. That's all this is. There's a machine that records when shaking starts occurring. So like here's nothing, 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 nothing. Then there's a P wave. You can kind of see it's not as severe. And then the S wave comes along, a bit more severe. So the difference in the arrival time is we can use that to figure out how far away it is. So if we look at this, the thing you have to know, and if you read your paper, you'll see this. You need to figure out these distances, this time. So each one of these is 1 second. So then we just need to figure out how many seconds between the P and the S wave. So we just read 1, 2, 3, 4, almost 5. So if we call it 4 minutes and 50 seconds, as long as you're relatively close. So that's the difference in arrival time now. And then we're then going to use this chart right here. And we're going to figure out how far away, let me do a different one. This chart right here. And this is something that it's already been made up by scientists. They know this is really consistent thing. They know the P wave, distance over time. This is the time over here, travel time, and this is distance from the epicenter. So we know if we have two different things, we can match them up. We know we can figure out the epicenter distance that it's away. And if we look at this bottom here, just remember this is in thousands, 1,000 kilometers. This is 1,000 kilometers, 2,000, 3,000. Then we're reading this later. Remember, there's 5 graduations between, so we know each is 200 then. So 22, 23, 24, 26, 28, like that. Just keep that in mind. Then distance and travel time is minutes, and we've done that. If you remember, it's 4 minutes and 50 seconds. And what we're going to do is we're going to take an index card and we're going to lay it along this graph. But we know travel time over here, right? So if we do 4 minutes and 50 seconds, that's about here. We want to mark it on our graph, or you may want to label it, right? So call it BH. And then we're then going to take an index card. We're going to line it up straight as possible, so we get as accurate as possible. And try to get straight. And we're going to just draw this line right here, BH. And then we're going to mark this bottom part too. So we're going to try to get this as good as possible. So then we have an index card that has 2. This is the distance and travel time. We then take it and we match it up on these graphs, right, until they line up with each line. And if we take this, it looks like about the last, I think a good spot is probably about there. Right? If we then mark it down about here, that's BH. It's going to be 3,200. So then if we were going to write that on here somewhere, we'd say BH 3,200 kilometers. So then we know our distance to the epicenter. Then we can use that and put it on the map. So that's how we get to that. And then if we take our map, and every map has to have a key. If you don't have the key for the map, you can't use it. But then we then use this down here. We know there's our scale, right, in kilometers, has to match up. And then we want to go and spread this out so the radius is 3,200, right? 3,200 away. I'm going to adjust this here. A little bit less. I'm sorry, a little bit more. It's about 3,200, right? So then we find on the map Balboa Heights, because we have Boulder, Colorado, BC, and then Mexico City, but then here is Balboa Heights. We put the little pointer thing in the middle, as close as possible, and then we're going to draw our circle. Right, there it is. And then we have one radius away, so somewhere on this line is the epicenter. Then we're just going to do Boulder, Colorado, draw the circle, and then Mexico City, draw the circle, and there should be one place where all three circles meet. That is your epicenter. You want to make sure as you're going through the lab that you add these things in, right, like this. So there's Balboa Heights. We're not going to worry about this stuff. That was important. But we're going to do the difference between P and S wave, 4 minutes, 50 seconds, then distance is 3,200 kilometers. And then you write each one of these in. This, again, is based on what you read on the seismograph. So I think you should be able to do this lab now. And then answer the questions. There's some questions that go at the end after you complete analysis and conclusion. There's the second page. Make sure you fill all these in, and then you can either turn that into the site or bring that to class, and I'll give you credit for it. But let me know if you have any questions on this, and that'll give you a nice little lab or a nice little primer on earthquakes and how to figure out where they are. All right, hope you have a good day, and let me know if you have